In a previous video, I introduced conic sections, and in particular, I introduced parabolas that are mathematically expressed this way. X squared equals 4py. And remember, our concern when we studied those, what we were looking for the vertex, we were looking for the focus, and the directrix. And in a parabola that's written this way, this is a parabola that opens up. Remember, if it's x squared, it opens up or down. This particular one opens up. It has a vertex at the origin. This is kind of like a parent function. It has a vertex at the origin. And to get to the focus, you go up p units. And to get to the directrix, you go down p units from the vertex. Now, and this is a parabola that opens up. So to get to the focus, you would go up p units. To get to the directrix, down. Now, if we had a negative in there, this is a parabola that opens down. From the vertex, we would go down p units to get to the focus and up p units to get to the directrix. But what we're going to do in this video is look at what happens when you have parabolas that have this for their expression. This is the mathematical description of those parabolas. Well, notice, what you notice is it's not x squared, it's y squared. You have y squared equals 4px. So we have something that's going to look like this graphically. It's going to be a parabola opening to the right. It has of course, a focus, and the focus is still p units from the vertex, and the directrix is still p units from the vertex also. But notice that is horizontal, right? You're not moving up and down to get to the focus and vertex. You're moving left and right. So with this type, whenever you see the y squared, you realize, okay, I'm going to have a parabola opening to the right or to the left rather than up and down. And the things that I'm going to change to get to the vertex and the foci, to the focus and the directrix, it's going to be the horizontal component. I'm going to change the x's instead of the y's. I'm not going to go up and down to get to the focus and directrix. So let's look at an example. Here's one. We've got y squared equals 4 times 2x, and this 2 is p. So, first of all, the vertex. It's just 0, 0. Now, we say, okay, I've got to get to the focus, so I'm going to move horizontally. That means I'm going to add to the x, and there's my focus. That's the location for the focus. Now, to get to the directrix, you move to the left. Okay? So there's what that graph looks like. Okay? Notice here's my directrix. Here's my focus. Okay? Let's look at another example. Let's suppose you've got y squared equals 16x. Now, of course, with this one, we don't have 4 times anything. That's just right there in our face. We have to kind of have insight. 16 can be written as 4 times 4. So now we can clearly see what the p is. The p is 4, see? Because we have y squared equals 4px, p being 4. So now, if you talk about the vertex, it's just 0, 0. Then we're going to add 4, and then we're going to subtract 4 to get the directrix. And see, it looks, like the other one. Okay, so it's opening to the right. Both of these are. Now, let's look at this. Let's suppose we've got y squared equals negative 4px. Okay, now, just like with when we have x squared ones, we have it opening up and then the negatives opening down. This one, we're going to have a situation where we open to the left. Instead of up and down, it goes left and right. And so, it's going to look something like this, where to get from the vertex to the focus, we're going to move to the left. To get from the vertex to the directrix, we move to the right. So, Let's look at an example here for this one. So we've got y squared equals negative 4 times 2x. Now clearly you can still see that the p is 2. However, that negative tells us this thing is opening to the left. So that doesn't change the vertex. However, it does change how we get the focus. To get to the focus, we're going to move to the left 2 units. To get to the directrix, we move to the right 2 units. To get this. Okay? This is what the graph looks like. So what we're trying to do, our whole goal here is to find the vertex, the focus, and the directrix in each one of these. And in the past, we've learned how to find roots and y-intercepts, and that's the y-intercept. But here we're looking at, we're going a little bit different path. We're looking for different things. Now let's suppose we've got y equals negative 5/3 x. Well, I don't have 4 times anything that I can see readily. So remember the trick. The trick, just multiply the top and the bottom by 4. We got to get a 4 in there some way so we can, have a form that we can work with. So just multiply the top and the bottom by 4. That's legal, right? That doesn't hurt anybody. It's just multiplying by 1. And then we can pull one of the 4s on the inside and multiply by this 3. So now we've got y squared equals negative 4 times 5/12 x. And at this point, we know the vertex is 0, 0. Now, this is opening to the left. So we're going to subtract to get the focus. See, I subtract it from the x, and I add to get the directrix. And there it is. There's our lovely parabola sketched. Okay, now, here's the thing. We've got a couple of situations here. We've got y squared equals 4px and y squared equals negative 4px. And in each case, we've got the focus and we've got the directrix in each one of these. But notice that every time, here's what you keep in mind, the focus is always within the curve there, within the parabola. Okay, so that helps you to remember whether or not to add or subtract to get to the focus. Okay, so notice in each case we move left and right. From the vertex, we move to the right to get to the focus, to the left directrix if it's all positive. If you have a negative in there, you're going to move to the left to get to the focus and right to get to the directrix. Now let's look at what happens if we have some shifts like this one. Now notice we have x's and y's here. If you have a number in there in the parentheses with the y, that indicates a vertical shift. So in this case, right here, we have a vertical shift. We shift up 3 units. Now here's what I like to think about. When we're trying to find the vertex, we have 2 things. We have the x-coordinate and the y-coordinate. If we want the x-coordinate, we look for something inside the parentheses with the x, only we write the opposite of it. Well, there's nothing in there, so it's just 0. So the y-coordinate, we look over here, what's in here with the y? And we write the opposite of it. In other words, here is a negative 3, so we write a positive 3. That's the vertex. Well, now that we've done that, we look at this and we say, okay, I've got a parabola. It's a y-square form. It's opening to the right. So what I need to do is I need to move to the right 2 units to get to the focus. Oh, I almost forgot. This y equals 3, that's the axis of symmetry. Up until now, when we worked with these, the axis of symmetry has always just been the x-axis. But now we have this vertical shift. Our axis of symmetry has been raised up. So our axis of symmetry is always going to be the y-coordinate of the vertex when we're opening left and right. If we're opening up and down, it's the x-coordinate of the vertex. But here is the axis of symmetry right there. Almost forgot to mention that. Now to get to the focus, we're going to add 2 to the x-coordinate here. Okay. Then the directrix, we subtract 2, and there we have it. Okay. There's what the graph looks like, and notice the axis of symmetry here at 3. 1, 2, 3. There's the axis of symmetry. The axis of symmetry passes through the vertex and the focus. Now let's look at this one. Now, notice we don't have a vertical shift, we have a horizontal shift. And the vertex is going to be 3, 0. See, I get the x-coordinate from the parentheses with the x. Only if it's negative in front, I put a positive. If it were positive, I'd put a negative. And there's nothing in here with the y, so there's the vertex. Now, the axis of symmetry is just y equals 0. See? It's not been shifted up or down. The focus, we add 2 to the x-coordinate. Now think about the directrix. We're going to subtract 2 from the x. And there we have it. Okay, let's look at another one. Now we have 2 shifts. We have a vertical shift and a horizontal shift. Now, if we want to write the vertex, we've got 2 things, remember. The x-coordinate and the y-coordinate. We get the x-coordinate from the parentheses with the x, only the opposite. The y-coordinate from the parentheses with the y, only the opposite. So we get -5, 1. Now, we've got a parabola opening to the right. So I'm going to need to add 2 to this -5 to get to the focus. But before I do that, remember the axis of symmetry, y equals 1. Now we can get the focus. Add 2 to the -5, and we get -3, 1. Now we subtract 2 from the -5, and we get the directrix, and here's what the graph looks like. So look, we've got a couple of things here. First of all, notice there's no negative here, right? So this is just a parabola opening to the right because it's y squared, the vertex is hk, and the axis of symmetry is y equals k. It's just the y-coordinate of the vertex. Now, as far as the focus, we want to move to the right p units from h. So we just add p to h. As far as the directrix, we subtract p units from h. And we get something that looks like this. Now, if there's a negative in there, now we have a parabola opening to the left, but the vertex and the axis of symmetry are both still the same. However, to get to the focus, we subtract from h. We're moving to the left. And to get to the directrix, we add to h. And here's what that looks like.